Hi everyone, and you are welcome to Classes Relationships Conclusion Lecture. We reached to the end of this section, and thank you so much for your efforts to reach this point. In this lecture, I would like to recap all what it has been covered in this section. Mainly, this section has talked about classes relationships, and we see that classes relationships describe how classes and classes objects interact with each other. Mainly, we see that we have two types of relationships. We have inheritance relationship and we have association relationship. For the case of association relationship, we see that we have two types of this relationship. We have composition and aggregation. And if you want to differentiate between them, it depends on if the component class cannot or can exist independently of the composite class. In case of composition, it cannot exist independently, whereas in case of aggregation, it can exist independently of the composite class. After that, we've learned about name mangling, and we see that name mangling is just a technique to help solve the variable naming conflict between classes and subclasses. And we see that it's quite useful when we have methods overriding, and I need the child class object to get access to the parent methods. And because of this attribute actually, it cancels real Python support for class private members, and as I say, don't use this method to get access out of the class scope to the private members. This is not a good practice. Next, we have mentioned that for inheritance relationship, there are four types. And if I want to differentiate between these types actually, we differentiate between them depends on how many children classes and how many parents classes we have. So in case of single inheritance, we have single child and single parent. In case of multi-level inheritance, we have single child and multiple parents classes. So in this case, we have parent and grandparent. In multiple inheritance, we have single child and multiple parents. Whereas in hierarchical inheritance relationship, we have multiple children classes, whereas we have only a single parent class. The next idea that we've learned about is access modifiers. And we see that access modifier is just a way to determine the scope within which we can access to an attribute or to a method. We've seen that we have three types of access modifier, which are public, protected, and private. In the first case, which is public, you can access out of the class scope to methods or attribute. In case of protected access modifier, we can access to these methods or attribute only within that class scope or the children classes scope. In the last case, which is the most restricted one, which is private access modifier. So if I have a method or an attribute, if it's private, I can access it only within the class scope. Also, in this section, we've learned about abstract methods and abstract classes. And we said that abstract method is just a simple method that has a declaration, but it doesn't have any implementation. And if you ask me why we need abstract method, simply to create abstract classes. So we say that class is an abstract if it has at least one abstract method. And if you ask me why we need abstract class, simply in Python programming language, we create abstract classes in order to create interfaces, which are templates for other classes. And any class inherits an interface, it should re-implement all the abstract methods. And the very, very important point to keep in mind that you cannot instantiate objects from the abstract classes, because if you do that and this object try to call one of these abstract method, there is no implementation, so there is nothing to be executed. Therefore, it makes sense to not let you instantiate objects from these classes. Now, and after we have understood both types of these relationships, let's try to compare between them. First of all, in inheritance relationship actually, we are allowing a class to inherit all the methods and attributes from other classes. Whereas in association relationship actually, we are creating complex type by combining objects of other types. Inheritance relationship is described by the word is, so if I have two classes A and B, and A inherits B, so I say A is B. Whereas association relationship is described by the word has, so if I have two classes A and B, then I describe this relationship by saying A has B. For inheritance relationship, there are four types, which are single, multi-level, multiple, and hierarchical, whereas for association, we have two types, which are composition and aggregation. Finally, in inheritance relationship, the relationship is between a parent or base class and a child or derived class. Where in association relationship, the relationship is between a composite or container class and a component or content class. Now, and after we have understood all the details that are related to classes relationships, let's talk about their advantages. Number one, dry or code reusability. So what I mean by dry, don't repeat yourself. And this is actually what we are doing when we implement a relationship like inheritance, because at the end we are reusing the code which is available in the parent classes. Usually, when we have code reusability feature, at the end I'll have higher code maintainability. Why? Because less number of lines of code means less time for maintenance. And the last point that I want to mention is that by using this relationship, we will have higher code understandability and readability. Because by using this relationship, actually, we are representing the real world concept programmatically in the same way that we understand this concept in the reality. That's all for this section and for this lecture. Thank you so much for your time, and thank you so much for your great efforts.